This video discusses the sampling distribution for the analysis of variance. So the calculation of this F ratio has this F distribution. So any of your F statistics are going to fall within this F distribution. This is the sampling distribution for any of the F ratios that you could get. And there is this small portion, and this is about 5%. So this is like at a 5% area where you have the probability of statistical significance. So when you get an F statistic that's up here, this is where you know that you have statistical significance. Now the F distribution is positively skewed, and it's usually positively skewed in relation to 1. So the majority of your F statistics are found to be less than 1, but then when you start getting above 1 is when you start getting statistical significance. And in this high 5%, where you have usually these F statistics are above 3 to 5 and higher, then you're getting statistical significance. So the central F distribution is based on a standard F using the population, and it's setting that standard where you have the majority of your distribution to be less than 1. Now a non-central F is when you have a treatment included. So this is the actual F that's being calculated when you're using your data within an ANOVA analysis. And so what's happening is we are comparing the central F to the non-central F. And in that comparison, you get a couple of different things. You get the comparison, from the comparison, you get what is the error of your analysis, and you also get the significance of your analysis. And so if we know that the bottom 5% of the central F is where we will have statistical significance, then we extend that into our non-central F distribution, and we can establish what are the F values that we need to obtain to have a statistically significant difference between the groups. Now, the important thing to remember is this is just establishing statistical significance in saying that there's at least 2 groups within your sample that are statistically different. It's not telling you which of those groups are statistically different, nor is it telling you if your effect of the treatment or the effect related to that difference between group means is actually large enough to be practical and practically significant. So in the calculation of this non-central F distribution, where this is the distribution of the F statistic or the F ratio when you actually have a treatment involved. So this is what the distribution of F looks like when you are testing it in comparison to the central F distribution. And is really looking at the variation around the grand mean. So this is that mean with everybody all together. And then within that is looking at the between group differences around the grand mean and looking at the within group differences around the grand mean. And for both of those, it's really the sum of square units. And so the sum of squared units are used to be able to get your mean squared value. And the mean squared value is used to get the F ratio. So this here is the F ratio. which is the mean square between divided by the mean square within. And this is what is getting you this F distribution, where the F distribution, and this is again the non-central F distribution, is this ratio of two variance estimates, which is these mean squared values. And this central and non-central F distribution are always positively skewed. And it's really looking at how much of your non-central distribution is falling within that 5% region of significance for the central F distribution. So this is part of how you are able to determine the statistical significance of your F statistic or your F ratio. But it's really important that that distribution of F is meeting the assumptions of ANOVA so that you are able to compare it to the central F distribution.